Khudani, Assistant Professor at LC Institute of Engineering and Technology. Today I will teach you unit number 3 of Mathematics 1, that is partial derivatives. Partial derivatives. Okay. If the function is of single variable, then we use ordinary derivative, and if the function is of two or more variables, then we use partial derivatives. To make you understand the concept of partial derivative, we need to understand the concept of limit and continuity. So the first topic is limit and continuity of functions of several variables. Limit and continuity of functions of several variables. Okay, now we will take first example related to this. First example is we have to evaluate the limit of the function limit xy tends to 1, 2 x square plus y divided by 3x plus y square. Now if you will put down directly the value of x equals to 1 and y equals to 2 in this function, and if the denominator is non-zero, then we can directly put the value of x equals to 1 and y equals to 2. If you will put x equals to 1 over here and y equals to 2, you will find that the denominator will be non-zero. So directly we can put the value of x equals to 1 and y equals to 2. So this is 1 square plus value of y is 2. Then after 3, the value of x is 1 plus y is 2 and it's square. 1 square is 1 and 1 plus 2, answer is 3. 2 square is 4 and 3 1 ja 3, so 3 plus 4 is 7. So the limit of this function is 3 by 7. Okay, now we will see second example. Evaluate the limit of the function limit xy tends to 0 0 y minus x divided by y plus x. Now we have to evaluate the limit of this function. If we will put x equals to 0 and y equals to 0 in the denominator we will be having 0. So we cannot directly put down the value of x equals to 0 and y equals to 0. So in this case, to evaluate the limit of such functions, we have to take different path. So first of all, we will take path number 1. Path 1, that is x tends to 0, then y tends to 0. So in this path, first of all, we will evaluate the limit of this function as x tends to 0, then after limit of the remaining function after simplification as y tends to 0. So we will write down this function as limit y tends to 0, then after limit x tends to 0, y minus x over y plus x. Okay, now first of all we will evaluate the limit of this function by taking x equals to 0. So this is equals to limit y tends to 0. If you will put x equals to 0 over here, so the function is limit x tends to 0 y over y, and y over y answer is 1. So limit x tends to 0 1, and now this is a constant function, so its answer is 1. So this is limit y tends to 0 1, and this is again 1. So along path 1, the limit of this function, that is 1. Now we will find out the limit of this function along path 2. Path 2, that is we will take first y tends to 0, then x tends to 0. Okay. So limit, first of all we will find out the limit of this function as y tends to 0, then after limit x tends to 0. So we will write down it in this way: limit x tends to 0, limit y tends to 0, and the function is y minus x over y plus x. Okay. Now first of all we will find out the limit of this function as y tends to 0. If you will put y equals to 0 over here and here, so we have minus x over x, and minus x over x answer is minus 1. So this is limit x tends to 0, limit y tends to 0 minus 1. Now limit of this function, this is a constant function, so answer is minus 1. So this is equals to limit x tends to 0 minus 1. So again it will become minus 1. Okay. Here you can see that the limit in path 1, that is 1, and in path 2, that is minus 1. So limit in both the path, that is different. So we will say that the limit of given function does not exist. Okay, now we will see examples related to continuity. Example number 3. Check the continuity of function of xy that is equals to 2xy over x square plus y square when xy is not equals to 0, 0, and this is equals to 0, 0 when xy is 0, 0 at point 0, 0. Now here we have to check the continuity of this function, right? When xy is not equals to 0, 0 and its value is 0 at point 0, 0. So we have to check the continuity of this function at point 0, 0. To check whether the given function is continuous at 0, 0 or not, first of all we have to find out its limit at point 0, 0, and then after we have to see its value at point 0, 0. If both are same, then we will say that the function is continuous at point 0, 0, otherwise it is discontinuous. So first of all we have to find out the limit of this function at point 0, 0. So to find out the limit of this function, as you can see, if you will put down the value of x equals to 0 and y equals to 0, so the denominator will become 0. So we have to find out the limit of this function by taking different paths. So first of all we will take path 1. Path 1, that is x tends to 0, then y tends to 0. Okay, so we have limit x tends to 0, then y tends to 0. So this is y tends to 0, limit x tends to 0, and function of xy is 2xy over x square plus y square. Okay, so first of all we will find out the limit of this function. So limit y tends to 0, we have to put the value of x equals to 0 in the numerator and denominator. So 2 into 0 into y, the result is 0. So this is limit x tends to 0, 0 over 0 plus y square. So the result is y square. So 0 over y square, answer is 0. So this is limit y tends to 0, and 0 over y square is 0, and limit y tends to 0, 0, this is a constant value, so the answer is 0. Okay, so the limit of this function along path 1, that is x tends to 0 then y tends to 0, is 0. Okay, now we will find out the limit of the function along path 2, that is y tends to 0, then x tends to 0. So limit x tends to 0, limit y tends to 0, and the function is 2xy over x square plus y square. Okay. Now here we will find out the limit of this function first. So replacing y by 0, so 0 multiplied by 2x, the result is 0, and divided by x square plus 0, so that is x square. So this is equals to limit x tends to 0, then after limit y tends to 0, and this is 0 divided by x square, and 0 divided by x square, the result is 0. So this is limit y tends to 0, the result of this limit is 0. This is x tends to 0. Okay. Now this is not a function of x, so limit x tends to 0, the result is 0. Therefore, the limit of this function along path 2 is also 0. In the path 1 it is also 0, so now we will find out the limit of this function along path 3, that is y equals to mx. If you will take y equals to mx, right? So y tends to 0, so we have mx tends to 0, okay? But m is a constant value, so indirectly we have x tends to 0. So in this case, the limit will be converted into a single variable, that is limit x tends to 0. So now, limit x tends to 0, the function is 2xy. So replacing y by mx, so it will become 2x into mx. So the result is 2x square into m divided by this x square plus y equals to mx. So its square will be m square x square. Now taking common x square from the denominator, so we have limit x tends to 0, 2x square m divided by x square common, so into bracket we have 1 plus m square. Now this x square will cancel out, and the function will be of function of m, right? And there is no x, so limit of this function, that will be m over 1 plus m square. Okay. Now as you can see, the limit of given function along the path y equals to mx is m over 1 plus m square. So it depends on the value of m. As the value of m changes, the limit changes. So we can say that the limit along path 1, path 2 and path 3 is not same. Okay, so we can say that the limit of the given function does not exist. So here the limit of function does not exist, so we can say that the given function is not continuous at 0, 0. The given function is not continuous at 0, 0, because to check the continuity of the given function, we have to find out its limit, right, and its value at point 0, 0, and we have to check whether they are same or not. If they are same, then we will say that the function is continuous at 0, 0. But here the limit does not exist, so we can say that the given function is not continuous at point 0, 0. Okay, now we will see problem number 4, that is check the continuity of function of xy. Function of xy equals to 3x square y upon x square plus y square when xy is not equals to 0, 0, and this is 0 when xy equals to 0, 0. Now we have to check the continuity of this function at point 0, 0. So for that purpose, first of all, we have to find out the limit of this function at 0, 0, right? and its value at point 0, 0 is given to us, that is 0. If the limit of this function at 0, 0 is 0 and its value at 0, 0 is given to us, that is 0, right? If both are same, then we will say that the given function is continuous at 0, 0, otherwise it is discontinuous. So first of all, we have to find out the limit of this function, and as you can see, if you will replace x by 0 and y by 0, so in the denominator we will be having 0. So we will find out the limit of this function by taking different path. So path number 1, x tends to 0, then y tends to 0. Okay, therefore limit x tends to 0, then y tends to 0. So limit y tends to 0, then after limit x tends to 0, and the function is 3x square y divided by x square plus y square. Okay. Now first of all, we will find out the limit of this function as x tends to 0, and then after the limit of that particular function after simplification as limit y tends to 0. So now we will put down the value of x equals to 0 over here. So limit y tends to 0. So this is limit x tends to 0. Now if we put down the value of x equals to 0 over here, so 0 multiplied by any value, the result is 0, and divided by 0 square plus y square, the result is y square, and 0 over y square, the result is 0. So this is limit y tends to 0, limit x tends to 0, and limit x tends to 0, answer is 0. So we have limit y tends to 0, 0, and this is again 0. So the limit of the given function, along the path 1 is 0. Okay, now we will find out the limit of the given function along the path 2, and path 2 is y tends to 0, then x tends to 0. Okay, so limit x tends to 0, limit y tends to 0. Okay, and the function is 3x square y over x square plus y square. Now first of all, we will find out the limit of this function as limit y tends to 0, and then after simplification we will find out the limit of that particular function as limit x tends to 0. So this is the path 2 as y tends to 0, then x tends to 0. Okay, now this limit x tends to 0. Now if you put the value of y equals to 0 in the numerator, it will become 0, and 0 divided by this y square, so 0 square is 0 divided by x square, and 0 divided by x square, answer is 0. So limit x tends to 0, this is 0, and limit x tends to 0, the result is 0. So the limit of the given function along the path 2, that is also 0. Now we will find out the limit of this function along the path y equals to mx, that is path 3, y equals to mx. Now if we replace y by mx, so as y tends to 0, then we have mx tends to 0, but m is a constant value, so we have x tends to 0, so limit will be converted into single variable. So limit x tends to 0, this 3 will be as it is, x square will be as it is, and y equals to mx. So x square into x, the result is x cube, m will be as it is, and divided by x square plus y is mx, so it is m square x square. Okay, now taking x square common, so we have limit x tends to 0, 3x cube into m divided by x square common, so into bracket we have 1 plus m square. Now x square will cancel out, so in the numerator we will be having 3xm divided by 1 plus m square. So this is equals to limit x tends to 0, 3 times x into m over 1 plus m square. Now if we put down the value of x equals to 0 in the numerator, the result is 0 divided by 1 plus m square. So the limit of the given function along the path 3, that is y equals to mx, again it is 0. Okay, now we will find out the limit of the given function along the path 4. Path 4, that is y equals to mx square. So again in this path the limit will be converted into a single variable, that is limit x tends to 0. So limit x tends to 0 and the given function is 3x square y over x square plus y square. Now in this function we will replace y by mx square. So this is equals to limit x tends to 0. If you will replace y by mx square, okay, so it will become m into x square. So x square into x square, so it is x raised to 4. So this is 3 into m into x raised to 4 divided by x square plus replacing y by mx square, so it will become m square x raised to 4. Now taking x square common from the denominator, so we have limit x tends to 0, 3m x raised to 4 divided by x square common, so into bracket we have 1 plus m square x square. Now x square will cancel out, so we have limit x tends to 0, 3m into x square divided by 1 plus m square x square. Now if we put x equals to 0, so numerator will become 0 and in the denominator we will be having 1 plus 0. So the result is 0 over 1 and that is 0. Now limit along the path 1, 2, 3 and 4, that is 0. So the limit of the given function x is, and that is limit xy tends to 0, 0, that is 3x square y over x square plus y square, and this is equal to 0. And the value of the given function at point 0, 0, that is also 0. Hence we can say that the given function, that is this one, is continuous at point 0, 0. Therefore the given function is continuous at 0, 0. Okay. So in this lecture we have gone through limit and continuity. 2 problems were based on limit and remaining 2 problems were based on continuity. Okay. Thank you for watching this video.